This lesson is going to piggyback off of the last lesson. The last lesson we learned how to write an equation for a set of data. Today we're going to use that equation to answer a question about the future. We're going to predict the future. So here's our problem. The table shows the number of hikers who have completed the Appalachian Trail from 1996 to 2000. Please put this table in your notes. In the year 1996, there were 405 hikers that completed the trail. In 98, there were 403. In 1999, there were 552. And in 2000, there were 623 hikers that completed the trail. Our goal is to make a scatter plot of the data so that we can write an equation to model that data so we can predict how many hikers completed the trail in 1997. If you notice, this table is missing 1997. Our goal is to figure that out. Okay, so your first step is going to be to make a scatter plot. When you make a scatter plot, you need to do a few things. So go ahead and put scatter plot. I'm going to do this off to the side here. I'm going to split screen this. Your first step is to make a scatter plot. When making your scatter plot, it's going to be very important that you label the x and y axis. It'd be a great idea to put a title to your scatter plot as well. Try to use the smallest intervals possible. You want your graph to be oh so precise. So use small intervals. This last step, your book's not going to tell you, but I'm going to tell you in order to make an equation, writing an equation easier, you're going to want to plot and label your ordered pairs. Okay, so let's do that. Take out that piece of graph paper. And start making your graph. If you look at our data only belongs in the first quadrant. We have no negative numbers. Okay. So here's my x-axis. Here's my y-axis. We're going to label that x and y-axis. We just wrote that down. Our x-axis, this is something new. We haven't done this before. Our x-axis is going to be years since 1996. Think about why I choose years since 1996. If I were to use 1996, 1998, 1999, 2000, think about how long that x-axis would be. You would have to make room for 2,000 numbers. Instead, I'm going to do years since 1996. This right here, the 0 is going to represent 1996. I'm going to let this represent 1997. 1 is going to represent 1997 because it's 1 year since 1996. 2 is going to represent 1998 because it's 2 years from 1996. 3 is going to represent 1999. 4 is going to represent 2000, and I think that's as many as we need. The y-axis is the number of hikers that completed the trail. So I'm just going to put hikers. And if you look at these numbers as well, they're high. You might have more graph paper room than I do, so maybe you're going to try to go up by tens. But to save room, because there's no numbers that are below 400, I'm going to put a break in the scale. And I'm going to start at 400. And I'm going to go up by tens. So 10, 20, 30, 40, 50. This is 450. 10, 20, 30, 40, 50. This is 500. 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. I'm going to stop even though there's a number higher than that. Now I can plot my ordered pairs. I'm going to use green so you can see it. Our first ordered pair is 1996, 405. Now again, my x-axis is years since 1996. 1996 is our first year at 0, so 0, 405 is on the y-axis. (1998), that's 2 years since 1996, is 403 hikers. 1998, that's 3, 552. 552. And then 2000 is 4 years after 1996. 623. Okay, so I just made a scatter plot. We did all of those things. We labeled the x and y axis, we had small intervals, and we plotted and labeled our ordered pairs. So let's see here. We did A. B says, find an equation that models the number of hikers completing the trail as a function of the number of years since 1996. We have to write an equation. Before we can do that, you have to draw a line of best fit. So I'm going to put that over here in our steps. Draw line of best fit. A line of best fit is a line that most closely follows a trend in data. You're trying to find the middle of the data. So when you draw your line of best fit, you want the same amount of ordered pairs. You're going to try to do this. You're going to try to get the same amount of ordered pairs above your line and below your line. When you draw your line of best fit, it's going to be very useful if you go through one of the original ordered pairs, or if you go through the grid marks on your coordinate plane. And I'll show you what I mean in a couple seconds here. You're going to want to say, go through 2 ordered pairs. That's supposed to be a G. Go through or I'm going to call them grids. And this is what I mean by that. When you draw your line of best fit, you're going to use a straight edge. And you kind of want to go in the middle of your data. So it just so happened when I drew this line of best fit, I went through 2 ordered pairs. That's going to be helpful when I write my equation, so I can find my slope very easily. Sometimes your data is not going to be as nice as this, and you will not be able to go through 2 ordered pairs that the table already gave you. Instead, you're going to have to find, maybe you go through 1 ordered pair, and you try to move your line so it goes through a grid mark. You see how this makes a cross on my grids? So I can easily tell that this ordered pair is 2, 480. This is what I mean by a grid mark. Instead of going through 2 ordered pairs, maybe it goes through a cross in your grids. Anyway, you have to find 2 ordered pairs. Either the ordered pairs they give you or the ordered pair that you have to find. It just so happens that we got lucky, so we can use these 2 ordered pairs. Okay, so step 3 is to write an equation. You want your equation to be in slope-intercept form. You can start with point slope if you want to, but make sure you solve for slope-intercept at the end. I'm just going to use point slope form. So with point slope form, M, and I'm going to need a B, and I'm going to do this right here. To find the slope, I'm going to, instead of using rise over run, I'm going to use the slope formula because it's kind of hard to read this graph. So I have the ordered pair 3, 552. And I also have another ordered pair 4, 632. I think it's 23. I think I said that wrong. The ordered pair 4, 623. To find slope, we do y2 minus y1 over x2 minus x1. I'm going to take my calculator. Let's see here. 623 minus 552 equals 71. 4 minus 3 is 1. And you're always simplifying. 71 divided by 1 is 71. Okay, now that I have the slope, I'm going to find my b. So to find my b, I'm going to use my slope and the smaller ordered pair. Plug it into this equation. Y equals mx plus b. 71 times 3 is 213. If b by itself, so 552 minus 213 is 339. Now I can write an equation because I have my slope and I have my y-intercept. Y equals 71x plus 339. Okay. Let's take a look at what our last step is. Let's go back to that first slide. So we made a scatter plot of this data. We drew a line of best fit so we could find an equation that models the number of hikers completing the trail as a function of the number of years since 1996. And the last thing they're asking is to approximate the number of hikers who completed the entire trail in 1997. Okay, so think this through. Think about the way that we made this graph. When we made this scatter plot, we did not put 1996, 1997, 1998. Instead, we used years since 1996. So you are not going to plug in 1997. Instead, you're going to plug in the years since 1996. The difference between 1996 and 1997 is 1 year. So we're going to plug in 1 into our equation. So let's go back to our equation. And I'm going to label this step so you can remember this step. Sorry. The last step is to substitute your x value in and solve for your y value. Substitute x value into equation to find y value. Okay, so our x value, we said, equals 1997. Well, we're not going to plug that in. Instead, we're going to plug in 1 because it's 1 year since 1996. Okay, so I'm going to plug that in. Y equals 71 times 1 plus 339. Okay, so I'm going to plug that into my calculator. 71 times 1 is 71. 71 plus 339 is 410. Okay, think about what this problem is asking. It is asking how many hikers completed the trail in 1997. We got, this is an approximation, estimation, about 410 hikers. Now, if we look at our table, that makes sense because if we go to 1997, which is 1, we get about 410 right here. Or if you go back to your table that they give us, in 1997, we're pretty close to those two numbers. So we have a value